question is from GATE 2021, Mechanical Engineering paper, Set 1, question number 18. A prismatic bar PQRST is subjected to axial loads as shown in the figure. The segments having maximum and minimum axial stresses respectively are. We have to identify from these four options which are the two segments which will have the maximum and minimum axial stresses respectively. Let's start by calculating the forces in each segment, because we know that stress sigma in any of the members is equal to force in that member upon the area of cross section of that segment. Now, as we know, the complete bar is prismatic. The area of cross section throughout the bar is uniform and every segment has the equal area. So we can say that sigma is equal to 1 by A into F, and 1 by A is a constant. We can write sigma is directly proportional to force in the member. That is, stress in the member is directly proportional to force in the member. So in order to find out in which segment there is a maximum stress occurring, we can find out the forces in all members and compare the forces. Member which will have the maximum force or the minimum force will have the maximum stress or the minimum stress respectively. I have separated out each of the segments of the given prismatic bar so that we can draw the free body diagram of the bar and find out axial force in each of the segment. This is segment PQ, QR, RS and ST. Always start from the free end so that whatever are the loads applied throughout the bar, we can find out the net effect at the support. The forces at joints S, R, Q as well as the force at support are unknowns, but we know that this is a determinate structure because there is only one unknown, that is the axial force at support P, and we have one equilibrium equation, summation f of x is equal to 0. All the forces in x direction are going to sum to 0 for this bar to be in equilibrium. So using this equilibrium equation, we will go on finding how much is the axial force in each of the members and the axial force at support even. At joint T, we have 25 kilonewton. So in order to satisfy summation fx to be 0, we'll have to balance it with a force opposite having the equal magnitude. Again the same thing at joint S, there should be equilibrium. So we'll apply 25 kilonewton opposite to what was applied at the right section of joint. This is the left section of joint. As per the diagram, this is the left section, this is the right part. Now next thing, we have 20 kilonewton negative. So let's write this 20 kilonewton. At joint S, the force that we obtain here is nothing but 25 minus 20, which is 5 kilonewton, and towards the right that is positive. So we have at this point 25 minus 20, which is 5 kilonewton. Now in order to balance this 5 kilonewton, we need to apply a negative 5 kilonewton. We need to balance it with a negative 5 kilonewton force. To balance this 5 kilonewton, same way we are going to have a positive 5 kilonewton at joint R. Now at joint R, there is external axial force, that is again positive 15 kilonewton. So this positive 15 kilonewton we can directly add to the 5 kilonewton we had earlier, because both are in the same direction, both are positive. So this gives us on the left section of joint R we have 20 kilonewton force. Same thing, to balance 20 we'll apply negative 20, and for balancing at the joint again positive 20. At joint Q we have again an external axial force which is 10 kilonewton negative. Hence we get 20 minus 10 positive 10 kilonewton. And at the support subsequently we will have, to balance this 10 kilonewton, we are going to have a reaction of negative 10 kilonewton. Now let's note down the forces in all the members. So let's say if this is member and we have forces in the member. First one, member is PQ, force in the member is 10 kilonewton tensile. Although nature is not required to find out the answer for this question, it's better to know. In segment QR, we have 20 kilonewton tensile again. Then in segment RS, we have 5 kilonewton tensile. And in segment ST, we have 25 kilonewton tensile. So as discussed, sigma is directly proportional to the force in member, and hence we can say minimum stress will be in RS and maximum stress will be in ST. Note that stress is independent of the length of the member. In this case alone, because it is not bending, this is a case of axial loading. So our answer here is ST and RS. That is option D. To learn more about the basics of normal stresses, you can refer to the NPTEL video Introduction, Strength of Materials, lecture series on Strength of Materials by Professor S.K. Bhattacharya, Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you with your doubt. Thank you.